the start node, which is start symbol, and go all the way down until eventually you get to the terminal symbol. So now, so the number of nodes, let's say, is at least mod v plus 2. But the first one, one of them, the bottom one, will be, the bottom node will be the terminal symbol, right? So all the others, so at least mod v plus 1, here's the critic, and here comes the crunch, here comes the denouement, the punchline. So all the other nodes in this path, they are variables, right? They're variable nodes, and the number of nodes in the total path is at least mod v plus 2. Okay, and one of those at least mod v plus 2 is the terminal node, so that all the others have to be variable nodes. So how many are there? Well, at least mod v plus 1. Yeah, one less. Mod v plus 1. But what is mod v? By definition, mod v is the number of different variables in your grammar. Okay? But we've now just shown that the number of variable nodes in the path from the root node to the leaf, in other words, the start symbol to the terminal symbol, that there are mod v plus 1 variable nodes, okay, plus 1. So you must have at least one of those variables repeated. Ta-da! Okay. Nice. Okay, so let's call that repeated variable. Let's call it R. R for repeat, right? And it has to appear on that path. We've proved that that's got to be the case. Okay. Now let's. Now it has to be there somewhere. Now, if you have repeats higher up, let's choose. For reasons of convenience, it'll become clearer later. But let's choose that repeat variable to be in the lowest of these nodes. Well, the variables. In your path, you have. You have this many, at least, right? At least this many variables in your path. So you may have more. So choose your R, your repeat, to be in the lowest of these variables going down your path. That aids the proof. All right. Now. Pretty well this we've done. It's just saying in words what I was, well, text written on the board, what I was saying verbally in the first session and second regarding the diagrams and the repeated R's. Okay, so go back to first and second sessions and you God. Derive and divide. Okay, so this is all effectively a repeat from what I'm doing. So I'll go through this fairly quickly. Okay, so each occurrence of R down the path, so you have a subtree under it. Okay, and that subtree will generate a part or a substring, a part of your string. All right. Now the upper repeat R that will generate a larger substring in your parse tree, and it'll generate VXY, whereas the lower occurrence of your R that will generate only X. Okay, because due to the smaller subtree. Just look at the diagrams; it's sort of obvious. Okay, now both of these subtrees, they're generated by the same variable. Okay, so you could substitute, just repeating myself here. So you could substitute one for the other, and you'll still get a valid parse tree. In other words, you get a derivation that's allowed, that's created by the grammar G. It's okay. Now if here's a repeat as well. So if you throw out the smaller subtree and replace it by the larger subtree, you still get a valid derivation, right? So and you keep doing that, well, you'll keep getting these multiples of v on the left-hand side of your x, and an equal multiple number of y's on the right-hand side of the x, and this pumped string is still derivable from your grammar G, right? So that's for I greater than 0. Now, what about the other case when I is equal to 0? Well, then you take the larger substring, throw it out, and replace it with a smaller one, and you'll just be left with this. Okay, and that's also possible. And then you're just left with this well, it's now a string. The v and the y is gone, and that's also allowable. That can also be generated by the grammar. My one question mark is one of the conditions was that vy, if you concatenate them, cannot be 0. But we do have this here. That's just my one question mark for the moment. Invite you to think about it as well. All right. So getting that far, that's now the proof. The formal proof we've done for condition 1. Effectively, condition 1 says that the pumped string also belongs to the grammar, or the language generated by the grammar. Okay. The pumped string belongs to the language. Okay, now we need to prove that conditions 2 and 3. We need to prove conditions 2 and 3. So, but that's next session. So we'll stop there.